So today we're going to look at solving quadratics equations. These are not technically quadratic. They're not just an x to the second power, but they are in that form. So for it to really be quadratic, you need to have three terms, two of them with variables, and one of them where the exponent is double the other. And you can see that in the basic setup of a quadratic equation here. The variables would be in the spots where your boxes are, and you can see that the one box has an exponent of 2, the other box has an exponent of 1, so one of the exponents is double the other. So the question is this first problem down here quadratic? If it is quadratic, go ahead and write it in the quadratic form. So you'll notice that we do have three terms. We do have two with variables, and this exponent of 6 is double this exponent of 3. So it is quadratic. So we can go 2 times something squared plus 1 times that same thing plus 9 is equal to 0. The question is, what does that box correspond to? Well, the box corresponds to the smaller of the two exponents. And if that is an x cubed, then this one over here would be an x cubed. And you should realize that a red x cubed raised to a power of 2 is really an x to the 6th. So it is quadratic. Now this one over here has three terms, two with variables, but your 4 is not double your 3, so it is not quadratic. Looking at these two here, are they quadratic? Well, you can see on this one on the right, it really is quadratic because you really have three terms. You're just missing your x to the 6th. And you could have put in 0x to any power, but if we put in x to the 6th, then we have three terms, two with variables, one where the exponents double the other. So if you would write it in quadratic, what would be your smaller exponent? X to the 6th is what goes in your box. This one over here, you have three terms, two with variables, and 2/3 is really double your exponent of 1/3, so it is quadratic. And you always put the smaller of the two exponents in your box. So it's an x to the 1/3 here, raised to the second power. Remember, an exponent raised to an exponent you'd multiply, and 1/3 times 2 is your 2/3. So being quadratic, we can use our quadratic formula. If it's not quadratic, we might be able to use sum of cubes or difference of cubes or other factoring techniques. So looking at this one here, it is quadratic. I've written it in the quadratic form where x squared corresponds to my box. My a would be what's in front of my box squared. My b would be what's in front of my box to the first power, and then my c would be the one that has no box by it. So when you're using your quadratic formula here, always go what's in your box, in this case x squared equals. If you forget to go x squared equals here, you're more than likely going to get the problem wrong at the end because you won't finish the problem. Plug in your a, your b, and your c. Go ahead then and work out what's in your root, remembering to carry down your what was in the box, your x squared each and every time. Then we can take the square root of 441, which happens to be 21. Now that we don't have any roots, we could go ahead and break this apart into two separate ones, 29 plus 21 over 2, and x squared equals 29 minus 21 over 2. Add these together, divide by 2, and subtract these, divide by 2. Then we could finish getting x by itself. This is where if you didn't go x squared equals, you probably would have stopped with a 25 or a 4. Solve each one of these. Remember when you take the square root that you get plus or minus, and there would be your two answers. Looking at this one here, it is not necessarily quadratic, but we do have three terms, two with variables. So the question is it sum of cubes? I'm not concerned about differences of cubes because I have a plus sign. So is 216 something cubed? Well, yes, it's a 6 cubed. So I could use my sum of cubes formula and factor that. My box corresponds to the x. My triangle corresponds to the 6. Now I have two things multiplied together to give you 0. The first parenthesis times the second parenthesis. Set the first parenthesis equal to 0. That's pretty easy to go ahead and solve. Then you could set the second parenthesis equal to 0, which happens to be quadratic, so you could just do the normal quadratic formula on the second set of parentheses here. Now you'd have the square root of a negative. Remember, that's going to give you an I. Square root of 108, look for factors that are perfect squares. That's a 36, still times another 3. So we get 6 plus or minus. The square root of that 6 is a 36 is a 6. Square root of that negative 1 is an I. Square root of 3 stays in there. Divide everything by 2, and we would get this. So we get 3 plus 3i root 3 and 3 minus 3i root 3 along with our negative 6 up here. Now notice over here we had 2 answers here, 2 answers here, a total of 4 answers. And you notice your highest exponent was 4. Here we had 1 answer here, 2 more answers here, a total of 3 answers, and you notice your highest exponent is 3. Your highest exponent will tell you how many answers you should get, unless they're fractional exponents. If they're whole number exponents like this, your highest exponent tells you how many exponents you should get. So go ahead and look at this one. You'll notice it is quadratic. You have 3 terms, 2 with variables, 1 that's double the other. So what would that box, if you write it in quadratic form, correspond to? Well, it's always the smaller of the 2 exponents, so that's an x squared. So we could go x squared equals, plug in our a, b, and our c, work out our quadratic formula. Inside your root, you get the square root of 64. You know the square root of 64 is 8. Nice, neat numbers. You could break it apart into 10 plus 8 and 10 minus 8, both over 2. Simplify each one. Then you want to go ahead and finish getting x by itself. So remember to write what's in your box equal to here so that you remember to do your last step here. Take the square root of both sides and take the square root of both sides. This one's also quadratic. You have 3 terms, 2 with variables, 1 exponent of 1/2. That's double the exponent of 1/4. So in quadratic form, it's like this here. So we go x to the 1/4 equals, do our quadratic formula, do what's inside of our quadratic formula, break it apart into a 1 plus 5 over 2 and a 1 minus 5 over 2. Simplify each one. 1 plus 5 over 2 is 3. 1 minus 5 over 2 is negative 2. Now we need to finish getting x by itself. So you need to think, okay, what do I have to do to undo that 1/4 power? Remember, a 1/4 power is a 4th root, so to undo a 4th root, you'd have to raise it to the 4th power. And raise it to the 4th power. Or you could think, okay, an exponent raised to an exponent, I'd have to multiply my exponents to get an exponent of 1. And so 1/4 times what is 1, and well, that is 4. So we're raising both sides to the 4th power.